Welcome to Math World. Today's class will solve problems based on division algorithm. This video is the continuation of class 4. There I have solved 3 problems based on division algorithm of polynomials. I have solved problems which involves division of the polynomials, and here I'm going with few more problems. Okay, all are the zeros of a polynomial if two of its zeros are root 5 by 3 and minus root 5 by 3. Here they are giving you two zeros of a polynomial of degree 4, so it can have at most 4 zeros, but they have given you 2 and the rest 2 you have to calculate. See, when the zeros are given, you know how to calculate the factors, right? That I have explained in the last video. See, this is the 0 means x equal to root 5 by 3 is one value and x equal to minus root 5 by 3 is another value. So you can say x minus root 5 by 3 is equal to 0. It's a one factor. Another factor is this, right? These two are the factors in fact, right? Factors of this polynomial, right? These two are the factors since they are giving you the zeros. These two are the factors, and see, this is a polynomial you will get as a quadratic polynomial when you multiply these two factors. This is the 4th degree polynomial, so you need to get 2 more factors. In the sense, you need to get 2 more zeros. So now these two are the factors. Then what is true? I can just multiply these two factors, right? I'll just multiply x minus root 5 by 3 into x plus root 5 by 3. What is this? A minus b into a plus b, right? It's nothing but a square minus b square. So you are getting x square minus 5 by 3, right? Now this is my g of x. Okay, the 4th degree polynomial which they have given is p of x. Let me take this as p of x. Okay, from these two zeros I got the factors, I'm multiplying and I'm getting another polynomial, that is g of x. Now I have to multiply this with p of x with g of x, so that I'll get 2 more zeros. Okay, so this is my g of x, x square minus 5 by 3 into, that polynomial is 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. Now I have to divide this. Yeah, I did the division part. You try by yourself and check with my answer. Okay, just to save the time, I just skipped the method of division. Okay, so I'm getting the remainder as 0. Now what does it mean? This polynomial g of x is nothing but this into this, right? Therefore I can simply write p of x, such a big polynomial, is equal to x square minus 5 by 3, that is my g of x divisor, into the quotient 3x square plus 6x plus 3, right? So p of x is equal to this. Now how will you get the zeros? In fact, you are just equating p of x to 0, right? In the sense, this is equal to 0 and this is equal to 0, right? So this is equal to 0 means x equal to root 5 by 3, x equal to minus root 5 by 3. This is already given to you. They have already given this. Now I have to equate this equal to 0, so that I'll get 2 more zeros, right? So these two they have already given. Okay, for that sake I'm just equating this 3x square plus 6x plus 3 equal to 0. You just take 3 outside, you'll get x square plus 2x plus 1 equal to 0. Now this is same as writing x square plus 2x plus 1 equal to 0. So x square plus x plus 1 equal to 0. X you take out, x plus 1 you take from the last two terms, you are getting x plus 1. So x equal to minus 1 and minus 1. Two zeros they are equal. Therefore, other two zeros are minus 1 and minus 1. Okay, this is another type of problem. They are giving you two zeros. Sometimes for a cubic polynomial they are giving you 1 0 and they'll ask you to calculate the rest too. Problem is this: you have to find the example, you have to write the example for p of x, g of x, q of x and r of x, which satisfies the division algorithm. Along with that, they satisfy these conditions. One example for this, this and this. Okay. So, what is the division algorithm? It says p of x equal to, division algorithm says p of x equal to g of x into q of x plus r of x. Okay. First thing is you need to find the polynomials in such a way that they satisfy this, along with they satisfy the condition degree of p of x is equal to degree of q of x. Okay. They are asking you to calculate, you to find the p of x and g of x in such a way that their degrees are equal and they satisfy this condition. Okay. So when I want to find this q of x, I need to take up the polynomial in such a way that by doing something to this p of x, I'll get q of x and r of x. That doing is nothing but the division. Okay. When it has to satisfy the division algorithm, so I have to go by the division method. So let me take, see, this condition is possible only when divisor is a constant term. See here, this is, I want degree of this should be equal to degree of this, right? Here this is possible only when this divisor is a constant term, right? So what I do is, let me take, see, if you want I'll just write, this condition is possible only when divisor in the sense g of x is a constant term. Okay, it's not a polynomial, I mean it's just a constant. Okay, it's a constant term. So that is possible. Let me take, for that sake I'll take a polynomial, say 3x square plus 6x plus 3, just as the previous one we did. No, I'll just write it this. Now this, if I have taken as p of x, its degree is 3. This has got degree 3. Now from what number I have to divide this so that degree of q of x is also 3. What I have to divide this p of x by what polynomial, so that I'm getting degree of q of x is also as 3. Okay, so just simple, I'll just divide by a constant 3. Okay, let me see now 3x square plus 6x plus 3, I'm dividing it by 3. What will I get? I'll get x square plus 2x plus 1. This is my q of x, right? So this is my q of x, and this degree is nothing but, I'm so sorry, I have written degree of p of x as 3. I'm so sorry, here it must be 2. It's a quadratic polynomial. I'm so sorry. See, now you observe, on dividing this p of x by a constant, I'm getting a polynomial of degree 2, which is same as degree of p of x. So this is the example for p of x, and this is q of x, and the constant term is g of x is 3 and r of x is 0. So this is the first condition. And another second one, they are saying it's satisfying the division algorithm, and along with that degree of r of x is equal to 0. I need to find the polynomials, to write the polynomials in such a way that it satisfies the division algorithm. Along with that, degree of r of x is 0. When the degree of r of x is 0, degree is 0. They are not giving you remainder itself is 0. They are giving you degree of r of x is 0. What does it mean? It means r of x is a constant, right? It just says, implies r of x, in the sense remainder should be a constant, right? Okay, so I have to find p of x such that p of x and g of x such that remainder should be constant. So it's quite easy. You just take some polynomial, a quadratic polynomial or linear polynomial. Okay. I'll take say x square plus 1. This is my p of x. Now I have to write g of x in such a way that when I divide this by this, I should get the remainder as constant. Okay, that you have to keep it in mind. Let me take this as x. Let me see. I don't know. I'm just checking. Okay. Now I'll divide this x square plus 1 divided by x. What happens? X square plus 1 divided by x. What happens? X into x square. That's all. You are getting the remainder as a constant. So my guess is correct. So that it works, right? You are getting p of x as x square plus 1 and g of x as 1. When you divide this, you are getting a remainder as 1. No problem. So r of x is a constant term. So these two gives you the values of p of x and g of x. So this is the example where you are getting degree of the remainder function as 0. Now the third condition, they are saying degree of q of x is equal to degree of r of x. This is quite interesting. So now I have to check with many possibilities here. This is possible. See, this is possible when you divide p of x by g of x, you have to get over here the remainder r of x. That should not be the constant term, in fact, because you are taking a polynomials here. So we'll try with examples and see which one works. Okay, the first possibility, I'll take same to this. Instead of taking highest powers, I'll just do a guess. Okay, p of x is equal to x square plus x, and I'll just take g of x, it's my guess, as x. Now what will happen when I divide this x square plus x by x square, then I'm getting again x, this is x, and I'm getting the remainder as 0. Right, it won't work now. When I take x, this is the x plus 1, this is the quotient which has got degree 1, but my and the remainder has got 0, so here this got degree 0, I'm so sorry, degree 0, it is not matching. Degree of q of x should be equal to degree of r of x, so this example won't work. I'm just trying with examples so that you can try your own examples. Okay, now I'll take up one more, say as p of x as same thing, x square plus x. There I have taken g of x as x, no? Now I'll take g of x as x square. Let me see what will happen. Okay, so that you can try by yourself. For that sake, I'm explaining with false examples, and then we'll come to the right one. So x square plus x, 1 gives me x square, so the remainder is x, and then the remainder is of degree 1, but the quotient is of degree 0, so again they are not equal, therefore this is also a false example. Okay, we'll take up one more. We'll take up p of x as same function, x square plus x. I'll just make a change with the g of x as say, what will I take? I'll divide this with the same thing. What happens? Let me see. Both are equal if I say. Then what happens? X square plus x, x square plus x. Okay, it's one time it's giving you this. Remainder is becoming 0, right? So this works. But this is not such a good example, in fact, right? Degree of this quotient is also 0 and degree of the remainder is also 0. It is not that much interesting. We'll take one more example. Say I'll just increase the power of this so that I'll get one nice example. Say x cube plus x, and let me take g of x as say x square. Okay, I just made a small change. Now I'll divide x cube plus x. Have to multiply by x so that I'm getting x cube, then I'll get x over here. That's all, right? So now the quotient function q of x is x, and the remainder function is also x. They are of equal degree, so my purpose is served. So here this is the best example, in fact, which says the degree of the quotient is equal to degree of the remainder. Okay, here I have 3 problems. Okay, you try by yourself. It depends on division algorithm only. We just mention this problem. If -2 is a root of this, then find the other 2 roots. Root means zeros. Okay, yeah. If you have any doubt regarding the topics I have discussed, please comment below so that I will come to know whether you are getting my teaching or not. Okay, thank you.